All right, here we go, the actual review now. So first things first, determine all the vocab. All right, so just everything that we've talked about really. And two things that I forgot to talk about in the last video. So first things first, what function is shown here? Well, here's what I'm gonna do. I'm gonna just highlight everything that we have here. I'm gonna highlight that maximum point, that minimum point, and then that midline is just right in between the two, right? Just right in the middle, halfway between them. So if we just want to talk about, the major 5 points here, it starts out at the midline, kind of goes down, then goes back up, and then ends back up at the midline. So it's hitting that midline 3 times, and we know that is the sine function. Now, remember, sine looks like this. All right, so it's being flipped upside down here. So it's really a negative sign. What function is being shown? I don't think they want us to get into the whole like writing the equation. That's going to come later. So right now we'll just call it the sine function. And here, we'll put an E on there. All right, the amplitude, how high up and down is it going? All right, so that's just going to be this distance here. All right, well, if you'll notice, we're going from -1 up to a +1. So the amplitude here is actually at 2, right? The vertical shift, notice how on this one here is kind of like our original starting point, right? And it's going down 1 spot, all right? So the vertical shift here, it's taking the entire graph and just pushing it down. So you could say down 1, you could say -1. -1 is probably a better thing to put. I'm just going to leave it as down 1, but you put -1. All right. Phase shift. Now that's how far is it being pushed back and forth. All right. So normally we start at 0, but it's kind of being pushed to the left. How far to the left is it being pushed? Well, all we have to do is just look at where this point is starting, and it looks like that's at -pi/6. All right, so the phase shift is going left pi/6. All right, and again, if you want to say negative, that's probably okay. I'm going to keep it as left pi/6 here. All right, that's just kind of the starting point. The period. How long is this thing lasting? So the period, that's actually, we have to figure out where it starts and where it ends. So it ends at pi/2. Right? Starts at, we said, -pi/6. All right, so to figure out how long the period is on this thing, all we have to do is subtract these two numbers. All right, so I'm just going to do the ending point minus the beginning point. All right, so this unit, there are a lot of fractions involved here. So let's just kind of recap. Anytime you add or subtract fractions, you need that common denominator here. So I'm going to go ahead and multiply both the top and the bottom of the first one by 3. That's going to give us 3 pi/6. And then minus a negative, that's plus pi/6. All right, so add those together. That's going to give us 4pi/6. All right, and you can always reduce your fractions. You should always reduce your fractions. That's going to leave us with 2pi/3. And again, if you wanted to do this on your calculator, if you don't like adding fractions, that's totally fine. What I would recommend doing is leave that pi off of there. All right, so the pi/2, just call that 1/2. All right, 1/2, and then minus, we're just going to call it -1/6. All right, so 1/2 is just 1 divided by 2. 1/6 is 1 divided by 6. Subtract them. It'll get you a decimal, and then you just go math, enter, turn it into a fraction, and there's your 2/3. And then just put the pi on the end of it. All right, so that is the period. So the period here was 2pi/3. The domain, easiest question on this entire unit. All right, sine and cosine, the domains, all real numbers. And actually here, I don't want to use that. Interval notation is negative infinity to positive infinity. All right, domain is the x values. How far to the left can our graph go? How far to the right can our graph go? Sine and cosine, they go on forever. We just kind of chop it off at one period here, right? And then the range on this one, just think, okay, what is the lowest point? The lowest point is at a -3. The highest point is at a 1, all right? And then put brackets on those because it's actually hitting -3 and it's actually hitting +1. Another way to figure out the range is just take the amplitude plus and minus that midline. All right, I'm sorry, the midline plus and minus the amplitude. All right, so you could do -1 plus or minus 2. Right, and then on the upper end that gives you 1, on the lower end that gives you a -3 here. All right, so that's another way to kind of think about it here. So the midline plus or minus the amplitude. All right, that's number 1. Number 2 here, they want us to graph this thing. They want us to find all of the stuff. So the amplitude, that's the easiest one. The amplitude is always just the number, right in the beginning. So the amplitude is going to be a +4. But keep in mind you have that negative number in here. So that negative in the very beginning tells us it's going to be flipped. All right, so remember sine looks like that. So it's just going to be flipped upside down. So we know when we graph this thing, it's going to start and end like that. All right. So let's see what we got here. The phase shift and the vertical shift. Vertical shift is always going to be that last number right on the end here. So that's just going to be up 2. All right. Let's see here. The period. The equation for period is 2 pi divided by our b value. Remember, the b value is the number that comes in front of the x here. So 1 period is 2 pi over 5. That is the length of 1 period here. The phase shift. The phase shift, I'm going to use PS. All right, so PS for phase shift is equal to a -c value divided by our b value. All right, so c value is pi over 3. So we have -pi/3. And then we have to divide that by the b value. The b value we said was 5. Right? So if we look at that, we have -pi over 15. All right, so what that means is it's going to push our equation. It's going to move it to the left pi over 3 spaces. So the phase shift left pi over 15. All right, I said pi over 3, sorry, I misspoke, pi over 15. All right, the domain, just looking at the equation, that's going to be -infinity to +infinity. Again, that's going to be the same on all of these types of questions. And then the range is going to be the midline plus or minus, or the vertical shift. So the vertical shift, I said midline on the previous page, the vertical shift plus or minus the amplitude. All right, so that gives us 2 plus or minus 4. All right, so that gives us 6 on the high end and -2 on the low end here. So the range goes from -2 to 6. Okay. So now the hardest part is graphing this thing. We figured out all the information, so now let's just put it on the graph. So here's what we can do. We know I'm going to put 5 blank spaces. Right? These are like, the 5 main points that we'd like to identify in our graph. So if you just think about the original function starts at 0, and then it has a period of 2 pi over 5. All right. So that's how long one period is before we talk about the phase shifts or anything. What we can do is we can start, chopping this in half. All right, this middle point right here, it's just going to be half of the maximum. So we have pi over 5. Chop it in half again. That's going to be pi over 10. All right, so we have 0, 1 pi over 10, 2 pi over 10. The next one gives us 3 pi over 10. All right, so these would be the points before any phase shifts. All right, but keep in mind, we have a phase shift. All right, that phase shift was negative pi over 15. All right, so what we need to do is we just have to subtract pi over 15 from all of these points. All right, so the first one, negative pi over 15. All right, and then the next one, pi over 10 minus pi over 15. I have no idea what that is. So let's just, go to our calculator here. So that's not my calculator. So I'm just going to say 1/10 minus 1/15. All right, and that gives me a fraction of 1 over 30. So I'm going to say pi over 30. All right, pi over 5 minus pi over 15. That one gives us 2 pi over 15. All right. The next one, 3 pi over 10. I can't do that one in my head. So we have 3/10 minus 1/15. That's going to give us 7 pi over 30. Right? And then the last one, 2 pi over 5 minus 1/15. All right, so if we think about this, this right here is equal to 6 pi over 15. Just multiply the top and bottom by 3, and then you're subtracting a pi off of that. This gives you 5 pi over 15. But again, we can reduce that, and we should always reduce our fractions. So we can call this one pi over 3. All right. So these are the 5 points on our x-axis here. All right. So here's what I'm going to do. I'm going to take all of those. Let's see if I can copy this. I'm going to put them up here. So these are our points. They're more or less in these spots here. So I'm going to call this negative pi over 15, negative pi over 30. And then, of course, we know our midline is going up 2 spots. So let's just call this 2. The amplitude, is 4. So we have to go 4 spaces above. So this is going to be a 6. And then 4 spaces below is going to be approximately, maybe right there. So we can call that negative 2. All right. And then since it's a sign, it's a negative sign. We know it starts at that midline. It bottoms out at negative 2, passes through the midline again, goes up to 6, and then comes back down to finish off at the midline. So this is what our graph looks like. And there we have it. All right. Next one is a secant function. So remember, with secants and cosecants, we have to graph kind of the main trig function here. So we know secant kind of matches up with cosine. So really what we need to do is we need to find the cosine function or the cosine graph it, and then kind of draw on those asymptotes here. All right. So first things first, amplitude is a 2, the vertical shift down 4, negative 4, whatever you want to say. Down 4 is probably a little bit better. The period, that's 2 pi over the b value, which is 2. Right, so 1 period here is just pi. The phase shift is equal to negative c. So negative 3 over our b value. So this gives us 3/2. And I forgot my pi. So it's 3 pi over 2. All right. So we're going to write 3 pi over 2. All right. The domain in range, we'll talk about that in a second here. So kind of like what we did last time, make 5 blank spaces. All right. Starts at 0. The length of one period before any phase shifts is the length of pi. All right. So we know it starts at 0 and ends at pi. That means halfway through is pi over 2. Chop that in half again. That's pi over 4. And then that last one ends up being 3 pi over 4. All right. But since we do have that phase shift, what we're going to do is we need to add 3 pi over 2 to every single one of these values. And that's going to give us our new ordered pairs here, or the new coordinates. All right. So the first one is 3 pi over 2. Right. We have pi over 4 plus 3 pi over 2. That's 6 pi over 4. That's 7 pi over 4. This one gives us 2 pi. 3 pi over 4 plus 3 pi over 2. 3 pi over 2. 6 plus that gives us 9 pi over 4. And then the last one here is 5 pi over 2. All right, those are the new kind of x values on this thing. So I'm going to take these and I'm going to kind of put them where they belong here. So it looks something like that. All right, so here are the x values. We have a cosine function, right? And it's not flipped, but it is shifted down 4 spaces. All right, so I'm just going to call this spot right here my midline. All right, so that's -4. All right, the amplitude is a 2, so that means it maxes out here. I'm going to call this -2. All right, and then it's going to bottom out. We're going to go ahead and call that -6. All right. And since it's cosine, starts up top, passes through the x-axis on that second point. It bottoms out at the third point, passes through the x-axis again on the fourth point, and then maxes out on that last point. All right, so here is your cosine function. Now, what we have to do is we have to think about where it crosses the midline, right? It crosses the midline at those 2 spots. What we have to do is we have to put some vertical asymptotes on these because it is it's a secant function, and the secant is 1 over cosine. So anytime it crosses that midline, we get a vertical asymptote here. And all we have to do now is just draw in kind of these U shapes. And that purple spot right there is what our graph looks like. That is the secant function, those purple lines. If we strip away everything else, all we're left with is the purple lines. That's kind of what our function looks like here. All right. Now, the range on this thing it goes all the way down to negative infinity, but it comes back up to negative 6. All right, that's kind of like the top of that U shape down there. All right. And then what we're going to do is we put this little u, the union. That's what we talked about. That means it skips over some points. And it's going to skip over everything between negative 6 and negative 2. All right, so it's going to start back up at negative 2, and then it goes up to infinity. All right, so that is our range here. All right, the next one, we have to be careful on this one because we have to exclude all of those asymptotes. All right, so we have an asymptote at 7 pi over 4, and 9 pi over 4, and so on and so forth. So what I'm going to do is I'm going to say x cannot be equal to, let's see, we have 7 pi over 4, we have 9 pi over 4. So how can we kind of come up with an expression for those? I'm going to say, oh man, let's see here. 7 pi over 4 and 9 pi over 4. Those are both odd numbers. Those numerators are odd numbers. So I'm going to say an odd pi over 4. All right. So if we kind of look back up here, what I mean by that is this next one right here would be like a 1 pi over 4. And then this one over here would be an 11 pi over 4. They kind of skip over all of those over 4 odd numbers that we have. So there we go. That is the first 3. Sorry, that video was kind of long, but there we have it.